Hello everyone, today I'm solving Leetcode question 126, word ladder 2. A transformation sequence from word begin word to word end word using a dictionary word list is a sequence of words begin word to S1 to S2 all the way to Sk such that each adjacent pair of words differs by a single character, single letter. Every Si for I between 1 and K is in the word list. Note that begin word does not need to be in the word list. And then this sk equals to the end word. Given two words, begin word and end word, and the dictionary word list return all the shortest transformation sequences from begin words to end word, or empty list if no such sequence exists. Each sequence should be returned as a list of the words. In the example 1, the input is begin word, hit, end word is cog. Word list contains hot, dot, dog, lot, log, cog. The output contains two lists, so there are two different ways to arrive at the end word from the begin words in the shortest transformation sequence. One way is from hit to hot to dot to dog and then to cog, and then the other one is from hit, hot, lot, log to cog. So there are two shortest transformation sequences. For the example 2, the return is an empty list because the end word cog is not in this word list. So compare with the previous question, word ladder 1. Word ladder 1 only asks you to return the shortest transformation steps. So how many, the length of the shortest transformation sequence. So for the word ladder 1, you only need to return, in this case, return 5 because there are 5 words in it. But this problem is more complicated than that because not only you need to identify the shortest transformations, the length of the shortest transformation sequence, you also need to print out all the shortest transformation sequences. There could be multiple ways to arrive at the end word from the begin word in the shortest transformation sequence. So the idea for solving that is using BFS+DFS to return all the shortest paths. You have this word list. The first step we need to do, similar to what we did for the word ladder 1, we need to construct a mapping dictionary. This mapping dictionary is constructed by masking one character at a time in every word in the word list. For example, for the first word, HOT, it has 3 keys: star OT by masking the first character, and then H star key by masking the second letter in HOT, and then HO star by masking the last letter in the original word HOT. So in this way, we create the key, and then the value is a list of words matching this pattern in the original word list. So this mapping dictionary will help us determine the next steps. So how we determine the next steps? Basically, given a word, we are trying to try different options to mask one character at a time, and then we see how many options, and we check how many words matching this pattern. So that's kind of the next word by changing one character. So this mapping dictionary is used to determine the next word when we traverse from the beginning words and then word by word until we reach the end word. And then we perform the BFS. So here there is a very important concept called BFS by level. So basically, remember in BFS, we are moving in the constant speed with the constant speed. So basically, BFS by level is like, so okay, first let's try to move one step. So from the current words, and then what are the next words we can reach within one step. So that's our next level. And then after that, what words can reach from the next level within one step. So that's kind of BFS by level. So the idea is first let's try to perform BFS by level, and then to identify, okay, what is the length of the shortest transformation sequence. And then by performing BFS, so we are tracking, so for each possible path, what is the previous word. So let's say if we are going from HIT and we can reach HOT, so we know that, okay, for HOT, the previous word can be HIT, so in the past. So that's kind of how we are tracking that. So the reason why we are tracking that is, in the end, we are actually going to perform DFS from the end word to reconstruct the shortest path. Why not from the beginning of the words? So from the beginning words, I mean, you may or you may not reach to the end word. But if you go from the end word, you are definitely going to reach the begin word. Because remember, we are only we keep track of the path, all the possible paths. So, okay, so let's code the solution. First, construct the word mapping dictionary. Mapping dictionary equals empty. And then for word in word list, for I in length word, if word I plus star, so we are replacing the character at position I with a star. So let's using the default dictionary. Mapping diction. So we construct the key. So this is our key. And then mapping dictionary key dot append word. So that's kind of construct the mapping dictionary to help determine the next words in the transformation sequences. After that, let's perform the BFS. So we are going to perform BFS by level. So we set the current level with the begin word. So that's our starting point. Well, we have elements in the current level. Well, the current level is not empty. For every word in the current level, and then for every character in this word, we're trying to basically, that's all the possible next steps. Before the start of the current level, we need to determine a next level and empty. And then next, okay, for I, in this length of word, we construct the key, and then next level dot append mapping dictionary key Okay, so I need to modify this line a little bit, but before that, so I mentioned that I need to track the travel directions. So, or let me try track previous equals. So basically, this is a dictionary key, a word, value, previous word in the transformation sequence. So we construct a key. Okay. And then we need to track the, okay, so we need to track if we have already visited a word before. Let's say if we already visit a word, then we do not want to repeatedly visit that over and over again. So we convert the word list to set. And then we remove that word from the word list. And then we check, okay, if key okay. So we need to append the next level. However, in this next level, we need to remove the word that has already been visited before. So in that case, let me check the mapping dictionary key. For the next word, if the next word so previously I need to remove all the word visited from the current level. So in that case, I need to remove everything from the current level. And then I check for next word if the next word in the word list, which means it has not been visited before. So in that case, I append that to the next level. And then, so after that, I need to update the current level to get ready for the next iteration. So one thing is we haven't really updated the previous one. So we need to actually update the previous one here. So previous next word dot append the word, because this is actually a path we are checking. So here, one thing I didn't consider is the stopping condition. If, okay. So let me use the set for the current level. So let me use the set instead of the dictionary, because I need to check if the AND word in the current level. In that case, I just break. So in that case, I just reach the end, and I find the shortest path. So what's the benefits for this BFS by level? Basically, it will get all shortest passes, since they are at the same level. They belong to the same level. For all the shortest paths, because they have the same length, so they belong to the same level. That's why we are doing the BFS by level. So while the current level is not none, so find shortest path by checking if this AND word in the current level. So for the current level, I use a set so that I can perform this find if AND word in current level in O1. That's why I change it from the list to the set. If I already find one, which means I reach I find the shortest path, I just break. And then the next level equals the set. And then I remove the current level from the word list because I start visiting that. So I convert the word list from the input list to a set. And then I remove the current level from the word list, so that I do not repeatedly visit the same word over and over again in different levels. And then for each word in the current level, and then I'm constructing the word pattern. So basically, the possible keys in this dictionary. And then after getting the keys, so mapping dictionary key will give us a list of all the possible next words. And then I check for each next word if this word in this word list, which means it hasn't been visited before. Then I added that to the next level. And then I track the previous word for this next word in this transformation sequence by append this word to the word to the next word. And then in the end, I need to assign the next level to the current level so that I can start the next iteration. So that's the BFS by level. So after that, we need to perform the DFS to reconstruct the shortest path. Basically, given a word, if this word equals, remember we are constructing the shortest path reversely from the AND word. And then we need to have a result. So So that's why we are reversing this list. So path is a list of the paths. So since we reconstruct the shortest path from the end word, so this path has words in the reverse order. That's why we want to reverse it and append it to the result. And then just return. Else for previous word in the previous DFS previous word has had the current word. And then let's just perform DFS for the end word and then empty path. So let's return the result. Okay. Line 26. Oh, should be in range. Line 40. Okay, should be in range. Okay, I forgot one thing. So remember, for the input is previous word, and then past word. So what is missing? It's missing the began word. So past. I need to add began word to the past. Yeah, so this is the solution. So this problem is pretty complicated. Let me just try to quickly recap the idea. So this problem asks you to print out all the shortest paths. So instead of like return the length of shortest path, it asks you to print out all the possible shortest paths. So for shortest path, we know that we should use breadth first search because every move has a constant speed. So every move is one step. And then this problem is a little bit more complicated since we need to print out the shortest path. So our solution or our strategy is trying to first find the shortest path using BFS, and then we are performing BFS by level. The reason why we are using BFS by level is that each level represent the one length, so one step. So, and then all the shortest paths, I mean, they will have the ending word in the same level. So that end word will be, let's say, for example, the end word is in level 5. So starting from the first level, our end word in the level 5. And then in that case, we know, okay, the shortest path is 5 here because we have 5 words in that transformation sequences from level 1 to all the way up to level 5. And then we know that, okay, so all the shortest paths should have the length 5. So that's why we are performing BFS by level. And then for the DFS, we use the DFS to construct the shortest path from the end word. The reason why we are not doing it from the beginning word is from beginning word, you may or may not reach the end word. But from end word, if you travel reversely, you will definitely reach the begin word. So that's why we reconstructed the shortest path from end word. Then how do we know what are the previous words in the transformation sequences? That's why we are using a dictionary. While we are performing BFS, we're using a dictionary to keep track of, okay, for each word in the transformation sequences, what are all the previous words in all different kinds of transformation sequences, including this word. So that's the overall idea. We use a mapping dictionary by changing one character at a time, by masking that one character at a time using a star in the word. For every word in this word list, we construct dictionary. This will help us determine what is the next word in the transformation sequences by tweaking one word in the current word. So that's why we're first constructing this mapping dictionary to help us determine the next word. We are constructing it by looping through every word in this word list and looping through every character in this word. And then we are just replacing that character with a star and then keeping all the other characters the same. That's how we construct the key for this mapping dictionary. And then we just append this word we just append this word. So which means, okay, for each pattern, for each key, we have a list of the words matching this pattern. And then previous is what we use to track of the previous word for all the words in the transformation sequences. So it's a default dictionary of list. So the key is each word in the transformation sequence, and then the value is a list of previous words in all different is a list of previous words in all different transformation sequences. The current word level, we set the current level, the initial level, to the begin word. We use the set because it will help us later first quickly check if the end word is in the current level. So that's why we use a set instead of a Python list. And then we convert this word list into a set. So the idea is, okay, once we check all the levels, we just remove all the words in that level from the word list. So to help us keep track of all the words we have visited in the previous levels. Well, the current level is not empty, and then we first check if we find the shortest path. If this end word in the current level, then we know that, okay, we reached the shortest path, we should just break. And then jump out of this while loop. If not, then we should start with it by constructing the next level. So we initialize the next level to an empty set. And then we just remove all the words in the current level from the word list, so that in that case, later we can check before adding the next word into the transformation sequences. We can check if that next word in this word list or not, to track or if this word has been visited before in the previous levels, so that we do not repeatedly visit the same words over and over again, especially in different levels. And then for the word list, so that's why we are performing the line to 39. And then for each word in the current level, we are trying to identify what is the next word by only changing one character in the current word. So we check for basically all the possible next words are stored in this mapping dictionary with the same pattern by changing one character. And then for this next word, we check if it's already in the word list. If it's in the word list, it means it's not visited in the previous levels. In that case, we add that to the next level. And then we also, okay, we have a transformation sequence including or contains the next word. So in that case, we use previous dictionary, this dictionary named the previous to track of the previous word of this word, of this next word in the sequence, so that it will help us reconstruct the shortest path later. And then in the end, after we finish and constructing the next level, we just assign the next level to the current level, so that we can use it in the next iteration. And then for this, after that, we finish all the BFS and then we find the shortest path, and then we use the DFS to reconstruct the shortest path from the end word. So we have a result. It's an empty list right now. So as long as we find the transformation sequence, the shortest one, then we just append that to the result list. And then we define our DFS function with the word and then also the current path. So if this word is in the equals to the begin word, which means, okay, we've already find a path. So we add the begin word to the path, and then we append that to the result, and then we return. So remember, for this path, we started from the end word. So that's why we need to reverse it before we add that to the result. And then if we haven't reached the begin word yet, so which means we haven't reached our ending point. So we check all the previous word in this dictionary, and then we just perform DFS for that previous word. And then in the end, this line 57 is just, okay, we start from the end word, and then we have an empty path. And then in the end, you just return the result.